Hey everyone, this is Dr. Walker. In this video, we're going to do a quick review of unit vectors and vector addition. Vectors are often expressed in terms of unit vectors. Unit vectors are dimensionless vectors having a magnitude of exactly 1. Unit vectors are just used to specify direction. So if a vector has a component in the x direction, you could specify that direction by using the I unit vector. If there is a component in the y direction, we use j, and a component in the z direction, we use k. The hat on top of the vector is used to denote that it's a unit vector. Again, it has a magnitude of 1, so it's dimensionless. It doesn't correspond to any kind of physical quantity. It's only there to specify direction. Let's say that we have a vector r. It's a position vector used to specify the position of this point x, y. So this vector r has an x component, so we can use the I unit vector to represent the direction, and then we would add the y component multiplied by the j unit vector to specify the y direction. So this vector r is specified with directions using the unit vectors. For 3 dimensions, we would just add a k direction. So that would be a vector that has some kind of z component. Let's say that we are given a position vector and that we're trying to find the unit vector for that position vector. How do we do that? What we do is we write the unit vector, and it's equal to the vector itself divided by its magnitude. We can use absolute value signs to represent the magnitude, but usually what we do is we just use a simple lettering, just not bold, just simple, to denote that that's the magnitude of the vector r. So we'll do an example to find unit vectors if we know the actual vector. Again, the unit vector is used to specify direction. So if we have a vector r, we would say that there is a unit vector r hat in this direction that points away from our origin point towards that point that this vector is describing. The last thing I want to review is vector addition. When we add vectors, we have to add the components separately. So in this case, let's say we have vectors a and b that we're adding, and I wrote them over here. So a is ax in the I direction plus ay in the j direction, and likewise for b. If we look at the resultant vector r, we know that it has an x component rx, and to get that we have to add the ax and the bx components of vectors a and b. So what we can do is we can say that the vector r is going to be the addition of ax plus bx, and that's going to be in the I direction. And then we can do the same thing for the y direction. The y component ry is going to be ay plus by in the j direction. So ay plus by in the j direction, j hat for the unit vectors. So that's how we add vectors. We can sometimes leave the answer in this form. We can note that the ax plus bx is called rx, so we can rewrite it like this if we want to, that the vector r is equal to rx in the I plus ry in the j. So sometimes we can leave our answer like this, but sometimes we need to specify the magnitude and the direction of our resultant vector. To do that, we can see that the magnitude of r, the length of r here, is going to be the hypotenuse of the triangle formed by the ax horizontally and the ay vertically. So to find the magnitude of r, we can just use Pythagorean theorem, rx squared plus ry squared. And to specify the direction of r, we can use an angle theta here. And we can write that the tangent of the angle is the opposite, which is the ry, divided by the adjacent here, which is the rx. We can use this to find the direction of the vector by solving for theta using the inverse tan of both sides. But what's great about the unit vector notation is that sometimes you can just leave your answer in this form, and it's a very quick process to add vectors, as we'll see in the next video that will have a couple of examples.